This is a presentation for a NPM package that I created, and the problem that it attempts to solve is dynamic forms. Forms that have inputs that tend to change a lot, and maybe adding a lot more inputs frequently, or regrouping those inputs. And for all of those changes, often there's changes that you need to make to the model behind that form. Maybe changing the shape of the model to allow for how you're changing the grouping of the inputs and so forth. So I have maybe a large complicated model that's changing quite often, and that creates quite a few challenges in the code. These are the main three challenges that I see with doing dynamic forms, and that is state management, validation, and persistence. So taking state management first, say like you want to update the phone number. You might create a reducer or a set state callback function that takes the original model, the updated information in that model, and then creates the next immutable progression that has that update in it. So in this case, it takes the new phone number, creates the new immutable progression of the model that has that new phone number in it. So it's kind of complicated because it's got all this nested spreading operation inside of it. It's actually not even complicated enough because it is not doing any null checking on the original model, because it's possible that original model.person is undefined, so when it tries to spread .contact onto that, it's going to blow up. It's not reusable. It only knows how to do phone number. And it's completely coupled to the shape of the model. So when the shape of the model changes, I have to rewrite all this. And you have to write a lot of these because this only knows how to do phone number. You've got plenty of other leafs here as well. So essentially you end up with a lot of complicated code that you're constantly needing to change. And that's just the state management. So the state management solution that this package proposes is that you don't have to write those reducers or callback functions, set state callback functions. You use a component like this, where you give it the model, so the whole model, and a function that can replace that whole model with the next immutable progression of it. And then you declaratively say what location within that model you're interested in for this component inside of it. So in this case, again, the phone number. So this will pull the phone number out of the model. It will get the phone number out of the model, pass it to this component, and then when this component wants to change the phone number, it calls this function that's on that component. And again, using the location information, it will do the exact same thing as a reducer or a set state callback, where it'll create the next immutable progression from the inside out and spreading the original references onto it. And this way, it's completely reusable because you can take this code and use it for any part of the model. It's as simple as it can be. You don't even have to write any reducers or set state callbacks, and it's loosely coupled to the model shape because the only thing that we need to change is just this declarative location that you're interested in the model. So the next problem would be validation. Say like a phone number is invalid. Now, if phone number is invalid, and say like there's a form that knows specifically about contact, you wouldn't be able to submit that form because phone number is invalid. So in other words, if phone number is invalid, then contact is invalid. And on that same token, if contact is invalid, that means person is invalid. So in other words, see like this leaf is invalid. That means that this object is invalid. And if that object is invalid, that array is invalid. And if that array is invalid, that object is invalid. So it's not enough to say that phone number is invalid. You can't just have validation states that know about the leaves. The validation model needs to have the same shape of the model that it validates in order to know, is this a location in the model? It could be this location, that location, that location. Is this location in the model valid? And that depends on everything beneath it. So again, your validation is coupled to the model as well. And when the shape of that model changes, the validation would have to change. So if there's a declarative solution for that, we can do that here. So this is the same as that previous example, all I did is add validation model and validators. So the validation model is built using this hook, and then you just pass it the model. And then you pass the validation model to the leaf. And then in this case, when phone number is invalid, and you declaratively give it the validators, which are just functions that return an array of problems, it will actually take that array of validation errors and assign it to that same location in the validation model. So the validation model is a parallel mirror of the model that contains, instead of values, contains the validation errors. And that way you can actually use this validation model object. There's some methods on it, and you can query what are the validation errors for any part of the model, and it will give you all the validation errors for everything beneath that part of the model. Also, the leaf component, it kind of makes the assumption that if you are creating this component here that is responsible for this leaf in the model, you probably want the errors just for that leaf. So that's what it will do here. Now, the last problem is about persistence. Not just persistence, but concurrent persistence. So say like you have user 1 and user 2 that download the same version of the same model, and then they make different edits. So user 1 changed the name, user 2 changed the email, and say user 1 submitted just before user 2. Now, this is what will end up being saved on the server. It's got the original name, because user 2 accidentally overwrote user 1 without knowing it. User 2 didn't change the name, user 1 did, but since user 2, just like user 1, submitted the entire model, and it originally had this name of Stewart, then it's going to override user 1. Worse than that, if there is a diff done on the server side to do auditing, that diff is actually going to record in the audit that user 2 changed the name from Stewie to Stewart, and that's not true. User 2 only changed the email. So to solve this problem, instead of setting the whole model to the server, what you really want to do is just send a diff that describes what the user actually changed. So in other words, a diff from what the user downloaded to what the user edited, everything that the user edited. So I've included two diff functions in this library that I'm not really going to go into detail for this presentation because it would take too long. But this is an example of a diff that would happen going from this original model to this updated model.